Question number 2. 2x squared plus x minus 4 equal to 0. So we are taking here method of completing the square. I hope that you remember the formula or the steps here. So the first step, one must have to remove the coefficient of x squared. So to remove this one with a constant value, you'll have to divide on both sides. So we get here 2x squared dividing by 2. Again here plus the coefficient of x, we have 1. So dividing by 2, x minus 4 divided by 2, which is also equal to 0 divided by 2. So here give the reason, that is what we did was, that is dividing by 2 on both sides. After that here 2 you can cancel, so we left with x squared plus 1 by 2 x minus 2 into 2 times, which is also equal to 0. That is the first rule. Second step, take the constant to the right hand side. So x squared plus 1 by 2x, which is equal to negative 2 changed to now positive 2. That is our second rule. The third rule, you'll have to get the value of b. So apply here identities. To get a value of b, what we do, just deno place you'll have to convert into double. 2 double of 2 will become, yes, that is 4. So now this can be read a squared plus, apply the identities, 2 into a. A means here only x. Into b, numerator, we take the same here, 1. But deno place, what we'll have to do, take the double of denominator. So double of 2 will become 4, which is equals to 2. After that here, to complete the identities, right now I've got here a squared plus 2 into a into b. Is it complete? No. So what you'll have to do, you'll have to add here b squared. So now plus b squared we need. And we know that a squared plus 2ab plus b squared is also equals to a plus b the whole square. Now you can complete the identities here by adding b squared on both sides. So we take here a squared plus 2 into a into b plus b squared. So 1/4 is our b squared, which is equals to 2. So plus again here 1/4 the whole square. Give here a reason, since that is adding b squared 1/4 where on both sides. After that here right hand side is very simple. Left hand side, apply the identities. We know that here a squared plus 2ab plus b squared equals to a plus b the whole square. So here who is a? A means x, plus sign, who is b? 1 by 4 the whole square. Now 2 plus, remove this bracket, 1 square equals 1, 4 square equals 16. After that here left hand side, you can drop the same factor, 1/4 the whole square equals, take LCM. So here 2 divided by 1. So 1 into 16 will be 16. 1 and 16, we don't have any factor other than 1. At that time, to get the value, take a cross. 2 16s are 32 plus 1 is 1. Again here x plus 1/4 the whole square equals 32 plus 1, which is equals to 33 divided by 16. Now 16 and 36, we don't have any common factor. So therefore x plus 1/4 equals, now take the square to the right hand side, it will take now square root of 33 by 16. Now here we have x plus 1/4 equals 33. Is it a perfect square? No. So keep within the root over, so square root of 33. But we can see here 16 is a perfect square of 4. Now here take a sign, positive also, negative, plus minus. After that you can separate this into two parts with a positive and negative. So we got here, after this step, now x plus 1/4 equals to, first take a positive root of 33 upon 4. We don't need to write here plus sign. After that here, take a collect a like terms, which is root of 33 by 4. Plus change to minus 1/4. Now take LCM, which is x equals, our LCM here will be 4, 4. So like terms, so we take one of it. Numerator plus will be the same here, 33 minus 1. So irrational, rational can be added or subtracted. Similarly, the second part, and the second part, x plus 1/4 equals, now we left with negative. So negative root of 33 divided by 4. After that here, I need the value of x equals negative root 33 upon 4. Positive change to here, negative 1/4. Now x equals to, take LCM here. The LCM will be again here, both 4. So it will be 4. After that, root of 33 minus 1. So again, irrational, rational can be subtracted. If you want here, you can increase one more step by taking the sign common. So negative, we are taking out here, root of 33 minus are plus 1. We can close, divided by 4. So give the conclusion by saying we are asked to find the roots. So therefore the required roots are, the required roots of the given quadratic equations are, the first one, root of 33 minus 1 divided by 4, and the second root, negative within bracket root of 33 plus 1, we can close, divided by 4. 4.3, question number 2. Find the roots of the quadratic equations given in question number 1 above by using the quadratic formula. So before we start here, do refer your notebooks. The formula is already given to you. So now here, first you'll have to know the discriminant formula. To get the discriminant value, we know that here b squared minus 4ac. And to find the roots by applying the quadratic formula, so you'll have to remember the quadratic formula that says here x equals negative b plus minus root over b squared minus 4ac divided by 2a. Apart from this one, the nature of the roots, if d greater than 0, then the nature of the roots will be real and distinct. And the second case, if d equals to 0, then the roots are real and equals. And the third one, d less than 0, that means it has unreal roots or no roots. So these 3 points you'll have to remember. D greater than 0, real and distinct roots. If d equals to 0, the roots are real and equal. If d less than 0, then it has unreal roots. Now to find the roots by using a quadratic formula. So now first we check the question here. We have got 2x squared minus 7x plus 3, which is equals to 0. So first get a value of a, b and c. So we know that the standard form of quadratic equations can be written in the form of ax squared plus bx plus c equals to 0. Remember that here a not equal to 0. Now here A, you'll have to take the coefficient of x square, B, the coefficient of x, and C will be our constant value. So from the given equations, A value, like you can see here, A is the coefficient of x square. That means here the coefficient of x square we have 2. B, the coefficient of x along with the sign you'll have to take, we have got -7. And constant value C, so which is we have got +3 or only 3. Now first get the value of discriminant. So which is equals to D equals to B square minus 4AC. So B value we can substitute here, -7 the whole square minus 4 into A, 2 into C, 3. So 7 square 49. Remember that whenever it has a power, even power, then always it will give a positive. So minus 4 2s are 8, 8 3s are 24. Then 49 minus 24 equals to 25. So what we can see here, you can compare with 0. Here 25 and 0. So I can say that 25 is greater than 0. So who is 25? 25 is discriminant. So then the nature of the roots are real and distinct. If the roots are real, then you can find the roots by using the quadratic formula. So now by taking the quadratic formula, we have here minus b plus minus root over b square minus 4ac. After that here, you can substitute the given values here. So minus the value of b, we have minus 7 plus minus root over b square minus 4ac. We already proved above here. You can see b square minus 4ac. We have got the conclusion 25. So now here we can straight away take the value, that is we already proved that 25. 2 into a value we have 2, so we can substitute. Negative are positive, so 7 plus sign minus sign. 25 is a perfect square of 5. 2 2s are 4. After this, you'll have to separate this into two parts. Say now x equals to 7, first sign plus 5 divided by 4, and x equals to 7 minus 5 divided by 2, which is equals to, so x equals to 7 plus 5, yes, 12 divided by 4. So x equal to 4 into 3 times. Similarly, x equals to 7 minus 5, that is 2 divided by, here I'm sorry, it is 4. So 4, then both this number are divisible by 2. 2 into 1 times, 2 into 2 times. So the required roots are, therefore, hence the roots are 3 and 1 by 2. Question number 2, sub question number 2, 2x square plus x minus 4 equals to 0. So before we start here, let's recall the standard form of the quadratic equations. So we have ax square plus bx plus c equals to 0. So now here, first get the value of a, b and c. So here ax square plus bx plus c equals to 0. So a means you'll have to take the coefficient of x square, which is from the given equation, the coefficient of x square we have 2. B, the coefficient of x. So the coefficient of x, which means here always they used to carry 1. Now c, which is our constant, which is -4. So minus 4. So apply the discriminant formula. D equals b square minus 4ac. Substitute the value of b. We have 1 square minus 4 into a, 2 into c minus 4. After that here 1 square equals 1. Negative, negative are positive. 4 2s are 8. 8 4s are 32. 32 plus 1, which is equals to 33. After that, then, like I said before here, the first part, if d greater than 0. So right now here 33 is known by value of discriminant is greater than 0, then the roots are real and distinct. So therefore the roots are real and distinct. After that, since the roots are real, you'll have to find the roots by using the quadratic formula. So we have here x equals minus b plus minus root of b square minus 4ac upon 2a. Substitute the value of b minus the value of b, we have 1 plus or minus root over b square minus 4ac. We already proved above, that is 33. So we can take here the value 33 upon 2 into a value, which is we have here 2. So substitute here 2. Now negative 1 plus minus 33, it is not a perfect square. We can keep within the square root of. So again 2 2's are 4. Now you can separate this into two parts. Now x equals negative 1 plus root of 33 upon 4, and the second part will be x equals negative 1. So the second sign we have negative root of 33 divided by 4. Rational, irrational can't be added or cannot be subtracted. So we can just keep up to there. Hence, or therefore, the required roots of the given quadratic equations are negative 1 plus root of 33 divided by 4. And here, if you want to take common, you can increase one more step by taking here common, which is minus 1 minus minus plus root of 33 divided by 4. The second root negative, so 1 plus root of 33 divided by 4, or you can just keep up here negative 1 negative root 33 upon 4. Question number 2, sub question number 3. 4x squared plus 4 root 3x plus 3 equals to 0. So first get the value of a, b and c. So a, we take the coefficient of x squared, we have 4. B, take the coefficient of x, so 4 root of 3, and c will be a constant, which is we have 3. Now get the value of discriminant, and d formula is, yes, that is b square minus 4ac. After that, substitute the value of b, which is we have 4 root 3 the whole square minus 4 times a, so 4 times c, so that is 3. Now here the power square belongs to both the numbers, so 4 square, which is 16 times here. After that, root 3 into root 3 equals to 3. So here square and root we can cut for this value, so we get here only 3 minus 4 4s are 16, 16 3s are 48. So 16 3s are again 48 minus 48. So 48 minus 48 equals to 0. Then what will be the nature of the roots? Like I said on a previous question here, if d equals to 0. So what is d here? 0 equals to 0. That means the nature of the roots will be real and equal roots. So therefore, we can say that the roots are real and equal. So since here the roots are real, you'll have to find the roots by using a quadratic formula. By applying the quadratic formula, we have x equals to, now recall the formula. Yes, that is minus b plus minus root over b square minus 4ac upon 2a, which is equals to minus. Now take the value of b. We have 4 root 3 plus minus root over b square minus 4ac value we already got above 0 upon 2 times of a, that also 4, which is also equals to negative 4 root 3 plus minus is a perfect square here 0. After that here divided by 4 2's are 8. Now which is equals to minus 4 root 3 divided by 8 plus 0 if you want, and the second one x equals to minus 4 root 3 divided by 8 minus 0 if you want to put. After that here, which is equals to, then x equals to minus 4 root 3 plus 0 will remain the same here. These two are divisible by 4 table, so 4 into 2 times, so minus root 3 divided by 2. Similarly here, x equals to minus 4 root 3 minus 0 will give the same result, so minus 4 root 3 divided by 8. Again here you can cancel by 4 table. X equals to minus root 3 by 2. Therefore the roots are negative root 3 by 2 and negative root 3 divided by 2.